Welcome to Sri Chaitanya. This is Umasankar, All India IT Coordinator. Welcome to JEE MAX, season number 2 of JEE MAX. Through this season, we are completely concentrating on a particular chapter, which is very, very important for both mains and advanced examinations of that complex number series 1. So far, we have successfully completed 54 lessons. This is lesson number 55. And with these lessons, we are concentrating on De Moivre's theorem of the complex numbers. And we are solving the problems of the De Moivre's theorem. And again, I am requesting, please don't forget to check the description. There I am providing links of all previous classes. And in this lesson, lesson number 55 of De Moivre's theorem, so we are solving the problems of Icon integrated textbook. Today we are concentrating sixth problem 1, 2, 3. Now, coming to the sixth problem. Yeah, it is somewhat a tricky question. If this question is given for you in objective type of examination, my suggestion would be you go for a particular case. That means you stick on to n is equal to some 4 or some 3 and you verify the options given in the multiple choice. Whereas if it is an analytical question, then things should be the different one. And again, my suggestion is, while looking the given question itself, immediately in your mind, if you are getting this kind of idea, then problem become very simple for you. Because there in angle of cos 2k pi by n is there. That in general one can get with the help of nth roots of unity. It appears like what? Real part of the nth roots of unity. So something, there should be some magic in that one. So here what I am doing is, now I am concentrating, purely concentrating nth roots of unity. Of that I need to focus on real part of the nth roots of unity. So before that, let me expand the given summation, and because from k equal to 1 to n minus 1, let the sum be, yes, say, let the sum. So consider this value, this summation, n minus 1 into, because if I have run the show, if I ran the show, n minus 1 into alpha plus n minus 2 into alpha square, n minus 3 into alpha cube, you consider this one, plus 1 into alpha power n minus 1, where alpha equal to e power I 2 pi by n. This is what? Nth roots of unity. That is cos 2 pi by n plus I sin 2 pi by n. So alpha square means cos 4 pi by n plus I sin 4 pi by n. Alpha power n minus 1 means cos n minus 1 pi by n plus I sin n minus 1 pi by n. That's right. So, if you have observed all the terms very carefully in the summation, yes, the first factors, they are in AP and the second factors are in GP. So, this is what an AGP. Now, I need to find its sum. For that, here I have applied the beautiful technique. So, the common ratio of the GP is alpha. Now, I have multiplied alpha with the S, and I have shifted one term and I have kept all the terms next to the above equation, and I am subtracting from equation 1 and 2. Okay, so what I did, I multiplied equation 1 with alpha. That means n minus 1 alpha square. I have written that term in below of n minus 2 alpha square, and continuously I have continued it, and I considered that as equation number 2, and I have subtracted from 1 and 2. So what happens? 1 minus alpha into S is equal to, this is n minus 1 into alpha minus of, so from these two, I may get alpha square. This after simplification, I can get 1 only. This after simplification, again, I can get 1 only. So in bracket, I can get what? Alpha square plus alpha cube and so on. Alpha power n minus 1 minus alpha power n. So this is 1 minus alpha into S is equal to n minus 1 into alpha. This is what sum to, this is in GP. This is in GP sum to n minus 2 terms. So conveniently what I did was, I have added first term and next term, 1 plus alpha, and I have similarly subtracted the same terms. Therefore, it is what? Sum to first n terms. Therefore, that is what? Alpha power n minus 1 by alpha minus 1 minus 1 minus alpha. Of course, minus alpha power n is there at the end. So again, after simplification, all these things, I can get this as n alpha, because my alpha power n is equal to 1. Because if alpha is nth root of unity, then alpha power n is equal to 1. That is the lambda. So finally, what I got? 1 minus alpha into S is equal to n alpha. So S is equal to n alpha by 1 minus alpha. What is my alpha? E power I 2 pi by n. So you simplify this. How to simplify? N into e power I 2 pi by alpha means what? Cos 2 pi by n plus I sin 2 pi by n by denominator is what? 1 minus cos 2 pi by n minus I sin 2 pi by n. Clear? This I can again write it as, see, this is 1 minus cos 2 pi by n is, I can write it as n into cos 2 pi by n plus I sin 2 pi by n by 1 minus cos theta is 2 sin square theta by 2, that is pi by n, minus 2y sin pi by n cos pi by n. Again you take n into this, I can write it as cis 2 pi by n by, you take from the denominator 2y sin pi by n. If I have taken from the denominator like this, this becomes cis minus pi by n, I can write. Cis minus pi by n I can write. So if I bring all the terms to numerator, then after simplification, I can get this as what? Minus n by 2 into 1 plus I tan pi by n. Clear? So it is very simple for me to compare real part. What is real part? Real part of S is, actually real part of S is what? N minus 1 into cos alpha plus I sin alpha. That means n minus 1 into cos alpha. And n minus 2 into alpha square. That means n minus 2 into cos 2 alpha plus I sin 2 alpha. That is alpha is here what? Cos 2 pi by n plus I sin 2 pi by n, like that. So if I have completely concentrated the only real part, I may get this as the summation. And of course my summation now it becomes what? Minus n by 2. So it is a somewhat what you call multiple angle oriented problem, and the problem involved with progressions and arithmetic geometric progressions and the concepts of arithmetic geometric progressions with de Moivre's theorem change. This kind of problems are very, very important for advanced type of examination than mains. So need to practice this kind of questions. Now coming to problem number 6, the second question. See, find the value of sigma k equal to 1 to 10. Sin 2k pi by 11 minus cos I cos 2k pi by 11. Immediately, while looking this question immediately, the term is the angle in between sin and cos. So this is the concept of 11th roots of unity. But it is not in my standard format. Because whenever we are expressing any complex number in polar form, first cos should be there, then only I sin. So this is not in the standard format. So what I am doing is, see the hint. So from this one, I have taken minus I common. If I have taken minus I common, automatically it becomes like this. Automatically it becomes like this. So this term in the bracket, I can write it as e power I 2k. Please practice this step. This is the golden point. Because since the given term in the bracket is not in the standard format, to convert them into the standard format, I have taken minus I common from the factors. Now it is in the form of e power I 2k pi by 11. That is what? 11th roots of unity. So let e power I 2k pi by 11 is equal to alpha. Therefore it becomes sigma k equal to 1 to 10 alpha power k. And you know it very well. If alpha is 11th root of unity, then sum of the 11th roots of unity, now I am going to find. That means alpha plus alpha square plus and so on plus alpha power 10. This I can write it as a into 1 minus alpha power 10 by 1 minus alpha. You simplify this. And alpha power 11 is equal to 1. Apply that. And you simplify this and apply that. You can get answer as I. Simple. Again here also, I have applied sum to n terms. Sum to n terms of GP. So whenever any complex problem linked with progression oriented this kind of models, they are always important for you, and in general in competitive examination they should ask this kind of models only. That's why first let us focus all the problems, solve all the problems which are given in the integrated textbook. That's why I am recommending first integrated person, get the knowledge from the integrated textbook, thereby With the help of these models, you can do wonders with all objective questions very easily. Okay, now coming to third problem. Yeah, here a double sigma is there. So don't get panic with these notations and all. So first try to understand the structure given it. Sigma m is equal to 1 to 4n plus 1 into sigma k equal to 1 to m minus 1 sin 2k pi by m minus I cos 2k pi by m whole power m. That we need to show that as I. Again, anyhow, the summation given in the bracket is not in our standard format. Moreover, 2k pi by m is given, so it is nothing but mth roots of unity. So what I did was, again, I have taken the term. Let's see, this, or I can do one thing. This I can write it as I power. This is that bracket, that term which is in the bracket. Sigma k equal to 1 to m minus 1 sin 2k pi by m minus I cos 2k pi by m. That I can write it as I. Why? Because just now we have solved this problem. Okay, according to this problem, the answer would be what? I. According to this problem, the answer is what? I. The same problem is here given. So, the immediately what I am doing is, just you follow the above problem. So, you replace the term in the bracket, this with I, so it becomes I power m. Again, you run the show. This is I plus I square plus and so on, I power 4n plus 1. Now, it is in again GP. So, sum to 4n plus 1 terms in GP. So, what is that? I power 4n minus 1 by I minus 1. You simplify that, you will get answer as what? I. It is very simple. Okay. So, my friends, this is another way to solve this problem. Of course, if you like this video, you please share and subscribe my channel, and please don't forget to press the bell icon, and we will meet with the next video soon. Thank you.